So thank you everybody for coming to another Serverless Toronto meetup. We are now virtual, unfortunately, but from the other side, we are fortunate because we can have a guest from around the world, like you, Yan. Thank you for visiting. And we did not spend much time mingling, introducing one another because it's almost midnight where Yan is. So I again reminder to do the survey because we're going to be giving two of the Yan's books. Like one is a course, one is a book at the end, courtesy of Manning Publishing and the book author Yan. And so for those who don't know us, we started like 2.5 years ago. As a regular backend developers, just gluing APIs and managed services, and that enabled us to build products faster. It drew attention of startup owners. It felt like a kids playing with Lego pieces that you are modeling MVPs and building products. It spilled also into UX design. If you look now, lots of Alexa and Google Assistant skills are based on serverless technologies. So it's not just the regular front-end developers who are getting superpowers, it's also alternative user interfaces. But when you overlay all these three activities together, you see that in the center of it is agility. Guys, can you hear me? Should I speak up? Is my microphone okay?
No, it's okay.
Okay, so it's agility. So I started to define serverless as the new agile because unlike Scrum, you're not sprinting faster. You're just using the bigger building blocks. And then, so this was a regular introduction we give on our meetups, what we are about. But then just last week, you probably noticed this ad by Yan Cui. He's our friend that's building Roombas in iRobot, and he gave this beautiful ad for the real position. So if some of you are looking for work, look at it. But this is the first time it's like almost like an anti-pattern. He's not looking for experience in serverless. You can learn that, but he's asking for serverless mindset. What that means that the focus has to be on creating value, not technology itself. Although it's a shiny technology, it's not the point. So closest analogy I would have is like this car mechanic that's all into their car, pimping it up, and the car is in the garage, but all we should be doing and should be enjoying to do is driving business and taking them places. So that would be closest analogy, and I'm excited to have more job postings like this because it's pretty dark in IT, as most of you know, and these meetups are events so that IT future can be better, but now it's turning into reality. So Ben, if you're listening, thank you, and good luck to anybody who's going to be working with him. It's going to be a fun job. Also, why we have all these meetup topics, I use this metaphor about Lego pieces. Like in order to build good models and prototypes, you have to have lots of building blocks. So how can you build something if you don't know the blue piece exists? So the purpose of these meetups was to enrich your toolbox so you know the technologies. Like a couple months ago, we had a graph databases. That's a topic we never knew, but now we know what types of problems we can use that Lego piece for. And also, having been almost 3 years in serverless now, I'm noticing misconception that serverless is Amazon. Yes, they started it first, but other cloud vendors do have good serverless offering. Plus, we're talking about the mindset. So I was also lucky that the next month in October, I'm going to have Kelsey Hightower as a guest. And for many of you, consider Kelsey as a Kubernetes god. So he was there first. He was like this car mechanic long ago, but his mindset is already serverless. So what Kelsey is doing now, he's bridging the serverless and containers world. And there is lots of coverage in the Google Next conference that's happening virtually over the 9 weeks of the summer, that he's going to be presenting and summarizing for us and giving you intro how to use serverless containers to run any workload, not just functions. So I'm excited about that as well. And then any of you, you're welcome to volunteer to talk. You don't have to be celebrity. You don't have to have perfect English. Listen to me. It's important that we are caring and sharing the ideas and helping one another be better architect and better developer. So that was about the group itself. Somehow in the process, as I was preparing Alexa talk, I became friends with Slobodan, who gave a Manning book that he was working on. He introduced me to Manning Publishers. I was already at the time consumer of your products. I think I have all of their books on serverless topics, including your products. And because you wrote 2 books, not one course and another book, Manning is generously giving away 2 products. In order for you to do that, you will need to fill that survey I pasted in the chat. I will paste it again, and we're going to draw the name. It's completely anonymous. We're not collecting information. You're just helping us suggest topics and best times to run these virtual meetings in the future. And now, to our feature presenter, Yan, we are blessed to have you. Thank you so much. So teach us what you know and introduce yourself to the crowd, and I will stop the sharing.
Yeah, sure. So I guess, hi everyone. Thank you for joining us. So maybe I can just go straight into sharing my screen, and then we can get started. I will introduce myself shortly as part of the main presentation. So Daniel, let me know when you can see my screen.
I can see it. Anybody else?
Okay, cool.
Yeah,
That's good.
Perfect.
Yeah, so fun story. Last time I gave this talk, someone reminded me that this pizza delivery guy is breaking COVID social distancing rules. He's getting a bit too close through your monitor. So COVID jokes aside, let's talk about the step functions. But like Daniel said, specifically focusing on how can we use step functions as a tool to help us deliver business value to our customers. So in terms of what's included in this session, this talk, I'm going to give a quick introduction to what is step functions, how it works, when you should think about using it, and also, I guess when you're building microservices, a question that comes up a lot is, well, when do you use orchestration versus choreography? Whereby instead of having a centralized component that controls the execution flow, you have just events flying everywhere, and you've got this event-driven architecture. So neither is better than the other. It's just a question of when do you use them based on the context that you're working with. And also, we're going to look at some real-world use cases for companies that are using step functions today, and some design patterns to finish off. So starting off with what is step functions? It's an orchestration service that Amazon released a couple of years ago that lets you model your business workflows as state machines. So basically, it manages the state of your workflow. It keeps track of where the execution is, and it gives you a scalable and a resilient platform to build your application on top of. And it allows you to focus on your business logic instead of infrastructure, as is the promise of serverless. You can design your state machine using this JSON-based language. I do strongly recommend you going through the official language spec. It has got tons of useful tips and examples that you can actually just copy and follow as you try to model your own business workflows. And if you design your workflow in the AWS console, you can also visualize your workflow as you work on it. I find this visualization particularly useful when I collaborate with non-technical users. So these are guys who probably are your product owners who maybe understands the business workflow itself, but doesn't understand technology and can't read JSON. What this visualization gives them is a way for them to follow along with what I'm doing, rather than getting distracted by the JSON syntax and all of that, which is great. It means that I'm able to design the workflow visually instead of using JSON, and this is a big feature gap that I see with some of the other services that you have with Azure, like Azure Durable Functions and IBM Node-RED, that lets you do this. Which right now with step functions, you can only visualize it. You can't design it with visually. You have to use the JSON. So once you've designed your state machine, you can start an execution of that state machine with some input. So in that sense, you can think of a state machine as a synonym for classes in object-oriented programming, and an execution is the equivalent for an instance of that class. And you can start multiple execution of the same state machine concurrently, no problem. So in terms of different ways you can start an execution, you can do that through the console, which under the hood just calls the step functions API to start an execution. So you can also do the same thing with AWS SDK as well as the AWS CLI. You can also trigger an execution with HTTP request with API Gateway, which integrates with step functions, both API Gateway, REST APIs, as well as the new HTTP APIs. And you can also trigger an execution using Event Bridge or CloudWatch events, as it used to be known, which basically allows you to trigger an execution of a business workflow when some event happens in your system, when they are captured and matched on the event bus, or you can schedule some state machine executions based on a cron expression as well. which is very useful for executing those cron jobs and maybe do some, I don't know, make complicated workflows like an ETL job, for example. And in most cases, the state in your state machine is going to invoke a Lambda function. And if you're using the serverless framework, then you should use the serverless step functions plugin, which lets you define the state machine in the same serverless YAML and then deploy the state machine with your functions as well when you run a serverless deploy. I should also mention that AWS SAM also has got the built-in support for step functions nowadays as well. So you have your state machine, you start an execution to do something, and then once an execution is started, you can also track its progress in the AWS console using that same visualization tool. So if you've got some branching logic, then you can see which path and a particular execution took, and then you can also inspect the input and output for every single state. So every single state or the green bit you see here on the screen, you can click on that in the console and see what is the input and output, and if there was an exception, what was exception details. So you can very quickly identify which step your execution failed on, and then you can find out what the error was. And the step functions also records audit for everything that's happening. So every time you call the Lambda function, every time it transitions from one state to another, that's all recorded in the event execution history. And it records up to 25,000 events when it starts, when a state ended, and so on. And for Lambda function invocations, you can also have a shortcut to the function as well as its logs. Although quite annoyingly, the CloudWatch logs link doesn't take you to the actual logs for that invocation, but just the landing page for the log group. So you still have to search for the relevant logs yourself, which is, again, a feature gap that I wish hopefully they'll fix at some point. And finally, in terms of the terminology, so every time the execution moves from one state to another is called a state transition. Now, the way the step functions charges you is by the number of state transitions you use. And the important point to note here is that even though it says state transitions, you are actually charged for the start and end state, the two yellow circles you see in this diagram, as well as the actual transitions in between them. And something that I had to discover painstakingly using AWS billing, because documentation is somewhat misleading. And at 2.5 cents per 1,000 state transitions, it's going to cost you $25 per million state transitions, which actually makes the step functions one of the most expensive services that you can find on AWS, and is easily over an order of magnitude more expensive compared to the Lambda invocations themselves, which is something that you need to take into account when you decide whether or not you should be using step functions. That being said, AWS did address this issue by releasing a much cheaper and more scalable variant of the normal state machines called Express Workflows, which is basically designed to support those high-throughput transactional systems. It doesn't have the visualization tool or the audit history in the console, but instead, all of your logs is going to get shipped to CloudWatch logs, but you can start 100,000 of these Express Workflows per second, so you can handle a lot of throughput, but they can only run for 5 minutes, whereas the normal state machine workflows can run for up to a whole year. So we're going to look at some real-world use cases a bit later on, at least the ones that are public, including from iRobot, which Danny just mentioned. Ben Cahill works there. So my name's Yan Cui. I'm an AWS Serverless hero. I've been working with, been building stuff on AWS for over 10 years now. Nowadays, I'm mostly focusing with serverless, including a couple of years ago when I actually worked on a project where I moved the social network to run entirely on serverless. So you can read about that on the link here. So nowadays, I spent half my time working as a developer advocate for Lumigo, which has built a debugging platform for serverless applications where you can make it really easy for you to find out what's actually wrong in your serverless architecture, where you can see the architecture components, API gateway, Lambda, DynamDB, and so on with within the transaction, but also see all the Lambda function logs, even when you've got multiple functions in the transaction side by side. You can also see how much time each step took, and also what is the request and response for, say, when Lambda calls DynamDB and so on, which makes the debugging problems a lot easier, especially as your architecture becomes more complex. The other half of my time I spend working as an independent consultant, where I help companies adopt the serverless so that they can go faster for less. I think one of you mentioned in terms of why you want to go serverless is because of cost, and that is one big driver for a lot of companies for why they consider serverless. But also more and more so, we're seeing people adopt serverless because they want to move faster, and not having to worry about infrastructure does allow your team to focus more on the things that they can do that's going to add business value, rather than spending time playing around with infrastructure. So in my free time, I done quite a few books and video courses, which you can all find on my blog, theburningmonk.com/courses. And as I was just talking to Daniel before we started, I'm also running a workshop this month. It's a 4-week workshop that takes you through everything about building production-ready serverless applications, from testing, event-driven architectures, building observability, security, and so on. The registration is open. We just started this week, so it's open till Thursday, so you have a chance to check it out. In terms of how you would design a state machine, in the step functions, there are 8 different types of states you can have. The most basic one is, or the most common one at least, is a task state, where you tell your state machine to actually do something. Typically, you do this by invoking a Lambda function. Now, the task state is identified by this type attribute as task. And in this case, we are going to say, please invoke this Lambda function, and we're going to give it the ARN, or the Amazon resource name for the Lambda function that we want to invoke. The function is going to get called by the current state of the execution, but we're going to talk about that in a minute. And once this task is completed, we can say, tell the state machine to transition to another state in the state machine by saying what that next state should be. And we can also optionally specify a timeout in seconds for this particular step in our state machine as well. So this timeout is optional. If you don't specify one yourself, then it's going to default to 60 seconds. One thing to keep in mind is that the state machine itself doesn't know the timeout value for your Lambda function. So even if the Lambda function can run for longer, because you've configured Lambda timeout to be, 10 minutes, the task state itself will still be timed out after this 300 seconds timeout value they've set. So typically, it's a good idea for you to set the same timeout seconds attribute here as you do for your Lambda functions configuration. And another thing to keep in mind is that a task state, it doesn't have to invoke a Lambda function. You can use it to integrate with a number of other AWS services directly. You can trigger an ECS task. I think someone mentioned ECS earlier, which can also run on Fargate as well, so you don't have to manage your ECS cluster yourself. You can also read and write data to and from DynamDB tables. You can publish messages to SNS or SQS. You can even trigger tasks in the AWS Glue or SageMaker if you're doing machine learning tasks, or you're doing some big ETL job that you want to trigger from step functions in the AWS Glue. And when you start an execution, you have to provide some input to your execution. This input is then bound to this dollar symbol and passed around into the first state in your state machine as input. And we can reference attributes of this execution state using this syntax like $.x to reference the value of the X attribute on the current input. Now, the conditions of our branching logic here translates to if X is greater or equal to 42 and Y is less than 42. So when this is matched, then the execution moves to the subtract state. And if you don't specify a result path attribute, then the output from whatever that state is doing is going to then override the current state and bind itself to the dollar symbol. So if that's not what you want, then instead what you can do is bind the result of a task, so a Lambda function's return value, to a subpath on the execution state instead, using this result path, which is what we've done here. whereby we tell step functions to bind the output of this subtract state to $.n. When the lambda function for subtract is invoked, we're going to get the current execution state as input, and which is going to have x and y, and we can access the x and y values just like attributes on the object. In this case, we're going to extract y from x and return that as output, which then is going to get bound to n. So after this subtract state, a lambda function is run and it returns 29, and the output is going to get bound to n because that's what we set as the result path. So then that entire execution state is passed as input to the next state in your state machine, in your workflow. And if we don't want to take the entire thing as input to our lambda function, we just want to pass in the value for n, for example, then we can use this syntax input path to specify what value on the current state is then passed as input to the task. So n with 29 here, and it's get bounced to the lambda's input variable here, and we're going to multiply by 2 and return that, and that's going to get mapped to the current state, which is going to be override the current execution state as $, so that's going to return 58. And since this is the terminal state or the end state for our state machine, we our whole execution state is going to return 58, and that's going to be the output for the entire execution. So this is how an execution state is sort of passed along and transformed along the way. As we see in a minute as well, you can manipulate the current state using a task, so a lambda function doing some input and output, and then you can also have just a state that just a past state, which basically is like a no-op, but what it does allow you to do is to modify the current execution state by adding attributes or doing something. So in this case, like we have the result path set to the answer to the question of life, the universe, and everything, and it's going to be bound to we're going to bound the answer 42, or rather is 42, to the current execution state, so that after this past state, our execution state is going to look like this instead. So, and silly as it may sound, one of the most powerful things that step functions can do or let you do is to wait, which is something that's really inefficient to implement with Lambda, because essentially you have to keep the function running whilst doing nothing, and you're also subject to the max execution time for Lambda of 15 minutes. With step functions, an execution can run for up to a whole year, and so you can have a wait state that waits for a very long time without having to pay for the idle time in between. You can also wait for a specific number of seconds or wait until a specific timestamp in UTC, but that's pretty static behavior, and often we want to decide how long to wait dynamically based on some input. We can do that in that case using this syntax, whereby we say where we specify the seconds path or timestamp path, whereby we say please find the value for the UTC timestamp or the number of seconds we want to wait by looking at this wait time or wait until attribute on the current execution state. So that allows us to control how long the state machines should wait for dynamically based on its input. And then we saw a bit earlier that you can do branching logic with the choice state, where you can specify basically some expression that checks against the current execution state. To say, in this case, if the name attribute equals neo, in which case a transition to the red pill state. Otherwise, it defaults to go to the blue pill state. If none of the branching logic match. So in terms of what can go into this branch logic, there's a lot of different things you can use. You can combine them with and or, and you can have a lot of different comparison operators to check string is equal to something, or Boolean, or numeric value, or if an attribute is present in the current state, and so on. And then we also have the parallel state, which lets you specify multiple branches of execution that can be run in parallel. And the entire parallel state itself is going to complete when all the parallel branches have completed, or when one of them has failed. If any of the branches ends in a failure, then the whole parallel state is going to end in a failure state as well. So the limitation with the parallel state is that the parallel branches you see here, they're static. They are defined in JSON. So you can't say run a map reduce job and control the degree of parallelism based on the number of items in an array, for example. To do that, you're going to need a map state. That's exactly what it's for, whereby it takes in an array as input, and you can dynamically create parallel execution branches that process these items in parallel, and you can control the concurrency with an optional max concurrency attribute. Whereas by default, step function is going to try to execute the iterations with as much as concurrency as possible. And then there's also some other state types like some state types like task, pass, wait, and parallel. They let you terminate the execution when they're complete, but not the choice state, in which case you may need to have a state that represents a successful sort of end to an execution. And that's what the succeed state is for. And similarly, you have the fail state that lets you mark the state machine execution as failed. And in this case, you must specify an error attribute with an error name and a cause attribute with some human readable message. So both the succeed and the fail states are what you call terminal state. So you can't specify any additional state transitions with next here. And also, finally, as well, you can also nest workflows together. So you can build bigger, more complex workflows out of smaller, simpler workflows. So some of the real-world examples we're going to look at in a minute could really benefit of this. So this came out was it 2019, and some of the examples I've seen in the wild in terms of what people are doing with step functions, you get some really crazy big step function or state machines, which can probably be broken up into nested workflows. So I guess a question you might be wondering is, when should you be using step functions, especially consider that it's one of the more expensive services you're going to find on AWS at $25 per million state transitions. And it's a lot more expensive than Lambda. And on top of that, it's also another moving part in your architecture, another service you have to learn and have to use. So, I mean, what exactly do you get in return, right? I think the cost is, definitely the biggest reason why you wouldn't use step functions. But Express Workflows kind of answers that. But it has got other limitations, as you mentioned, that it doesn't have the visualization tool, and it doesn't have and it can only run for 5 minutes, whereas normal state machine workflows can run for a whole year. And in terms of the pros, the visualization tool is very, very useful. Although, as I mentioned a bit earlier, you can't use it to design your workflow itself. Instead, it's there to give you a visual way to validate your design and to monitor and to debug executions at runtime. Another thing that I really like about the whole visualization is that it's also great for working with other team members who are not engineers and don't want to delve into the code. So, for example, it surfaces application logic in a way that anyone can follow, which is great for business analysts, for product owners, but also really useful for some of the QA engineers and the customer support teams who can go into the execution, some AWS step functions console, and see that for a particular execution where you failed, and probably get a good sense for why you failed as well, without having to dive into code and then trying to follow all this complicated logic and abstraction layers that you have that maybe you understand because you wrote it, but someone else coming in fresh and not really coming from an engineering background that may struggle to understand the actual execution flow for your application. Whereas when it's all surfaced up like this, they can get a much better sense of what actually going on inside your application without having to dive into the code. And also with the visualization tool, you can see almost in real time what is happening in your particular transaction, so that you can tell, okay, some payment process failed, and it was failed because we tried to talk to PayPal and PayPal returned 503 or something like that. So step functions gives you a lot of control also around error handling and retries. Because normally with Lambda, you can retry failed operations to DB or to whatever, but you have to constantly be working within the constraint of your timeout, which for most Lambda functions is pretty short. So whereas if you take some of the error handling and retry out of the function and into the state machine, then you can be much more relaxed about in terms of okay, how you retry and how much delay you put in between retries as well. So out of the box, you are able to configure the number of retries as well as the exponential backoff, so that you can add increasing delays between retries, and you can just keep on retrying for many times without worrying about, okay, my function is going to now needs like a 10 minutes timeout, because on the really rare occasion, it's going to have to retry this third-party service many times with a big delay between retries. That's what I was saying, that it makes it easier to work out what timeout to use for your Lambda functions, because you don't have to worry about adding those additional times you need for the retries and the exponential backoff. So so another advantage of moving this error handling and retries into the state machine is that it also surfaces this business logic into the workflow, which again makes them a bit more accessible to other team members who are not engineers. And finally, you have this full history of what happened during an execution, and the history is also retained for 90 days as well. So it's great from an audit point of view as well. So in the step functions console, you can also see a list of all the executions for a given state machine, sorted by start time. And if you click into one of these executions, you have a bunch of information about the execution at your fingertips, including the input and output for the whole execution, as well as the visualization of the path the execution took, and the outcome for every single state, as well as the entire execution. So if you click on one of these states, then you can see the input and output, as well as any exceptions for that particular state. You also have the full event history with timestamp and everything. You can expand that to see what happened for particular say task state. You can see the input and output for that Lambda function. And in cases where Lambda functions failed, then you can also see the exception details that's returned by the function as well. So with this high-level pros and cons in mind, I usually use step functions for 3 typical scenarios. One, when I have business-critical workflows, which are usually the things that actually makes the business money. For example, taking payments or signing up a new user. In this case, the extra premium that I'm paying for step functions is totally worth it for the more robust error handling. And also use it when I have business complex workflows that involves many different steps with branching logics and so on. So in this case, the visualization is a very powerful design tool because I can collaborate with the product team, and also serves as a very good way to diagnose problems that happens in the production, and very useful for customer support engineers you have as well. And lastly, I tend to use it for workflows that are long running. In this case, a Lambda function can only run for 15 minutes. And although there are different ways you can kind of sidestep that limit, including writing your function as a recursive function and so on, as an approach, AWS generally discourages using recursive functions because the developers often forget to implement the termination logic. So your recursion turns into infinite recursion, and it can be a surprise on the AWS bill at the end of the month. So with step functions, you have more explicit branching checks, and you can specify a timeout for the workflow level as well, which also helps to prevent those infinite recursions. So if you are going to do some recursion to implement some long-running process, then do that with step functions. And of course, you can do that. You can use the step functions to trigger Fargate or other containers or other tasks in ECS as well. And then with express workflows, I can use step functions in those high throughput scenarios as well. So you can still design your workflow using the same language, but there are a number of important differences to keep in mind. So here's a very useful page that outlines the main differences between standard workflows and the express workflows. So one big difference is that the express workflows only runs for 5 minutes, whereas a standard workflow runs for a whole year. And there are also really big difference in terms of throughput. So the normal step functions standard workflows let you start only about 2,000 executions per second, which is plenty for most people. But for some high throughput scenarios, you may want to go up way above that. And the express workflows can go up all the way to 100,000. So that is a lot. And this and there's basically no limit to the number of state transitions that you can have per second with the express workflows, whereas there's a limit of 4,000 state transitions with standard workflows. It's also priced very differently compared to standard workflows because it's based on the number of executions you run, their duration, and the amount of memory they use during the execution. And so for at $1 per million executions and 6 cents per gigabyte hours, it's very comparable to the equivalent Lambda cost you find, and it works out considerably cheaper compared to standard workflows. However, since you're likely going to implement most of your states in the most of the task states in the workflow using Lambda, you're going to incur the cost for both the Lambda invocations as well as step functions cost as well. So just bear that in mind when you're working out your total cost for implementing your workflows. So the bottom line is you should use the step functions express workflows for high throughput and the short-lived workflows, which is typical for a lot of the online transactional processing systems. The trade-off is that you no longer have the visualization tools, and you no longer see your audit logs in the step functions console, but they're still going to get logged to CloudWatch logs, so you can still ingest them yourself. And since the express workflows are designed to operate at a much higher scale, you also have the option to only log error messages, or you can exclude those execution data or turn off logging altogether, because at very high throughputs, that can generate a lot of data that gets sent to CloudWatch logs, which can also cause your cost to blow up, because CloudWatch logs charges something like 50 cents per gigabyte of data ingested, and also charges you for 3 cents per gigabyte per month for storage. So that's kind of when you would use the step functions and some of the sort of caveats about deciding when to use standard workflows versus express workflows. But then there's also a related question of orchestration versus choreography, especially when you're thinking in terms of microservices. Those are the two main forms of communication models of communication within a microservices architecture. And the step functions, be it standard or express workflows, are definitely in the orchestration camp, where your state machine is pulling the strings and controlling the entire flow of execution. So my rule of thumb is to use orchestration within the bounded context of a microservice, but use choreography between different bounded contexts. Because within a bounded context, I have a fairly focused purpose or set of responsibilities, and there are hopefully a small number of components that they can all fit inside my head at the same time. And since they all kind of work together to achieve some specific business capabilities, like processing payments, so they form this highly cohesive unit, and I own everything within this bounded context, so I'm free to change and reorganize things so long as I don't break my contract with other services. So I often see workflows within the bounded context being choreographed through messages in SQS queues or SNS topics, and generally speaking, I think they're a bad idea. So I love using events to integrate different services together, but I think it's a bad idea when it's done inside the same bounded context, because the workflow doesn't exist itself as a standalone concept and is not source controlled. It only exists as sum of a bunch of loosely connected functions, which makes them very difficult to reason about and debug. And to also, there's no easy way for you to implement even simple things like, timeouts, where you are having to rely on the absence of a value of an event to trigger something. But then when it comes to communication between bounded contexts or microservices, I will publish and subscribe to events through SNS, EventBridge, Kinesis streams, and so on, so that the different parts of the larger system can still stay loosely coupled, and they can build on top of each other's events, and they can evolve and fail independently. So on the topic of EventBridge and SNS, also wrote a blog post on why nowadays you should consider using EventBridge instead of SNS. It's for new projects where you don't have that constraint. But the choreography and the orchestration, they don't have to be mutually exclusive. I mean, for example, inside my state machine, whenever I'm introducing some state change, like changing the status of an order from pending to processed, for example, I can still publish those state changes as events to the event bus, so that other systems can listen in and react to those state changes, and therefore it brings the choreography back into the picture. So again, prefer orchestration within a bounded context, but use choreography between different bounded contexts to orchestrate, to communicate between different microservices. So with that, let's look at some actual real-world examples of how people are using step functions. Coca-Cola, for example, they run a state machine execution every time you use the vending machine. So, if I remember correctly, the problem they had was that as part of that execution, they needed to add the 90 seconds delay because of some legacy system they're talking to. And the step function was the cheapest and the most cost-efficient way and the most scalable way they found to do that without having to run a Lambda function for 90 seconds and doing nothing. And they also use step functions to update those nutritional information on something like over 100 different brands they have in order to comply with FDA regulations. And they managed to reduce the processing time for this process from 36 hours to 10 seconds using step functions, which is a pretty big improvement when you consider. And then there's also Thomson Reuters as well, which uses step functions to transcode video segments, whereby they will split the original video into multiple segments, and then they will encode them in parallel, and then they will stitch them together after they encoded the individual segments. So by moving to step functions, it helps them reduce their processing time from something like 20 minutes to 2 minutes, which is a tenfold improvement. Again, very good use of step functions, something that you will read about if you are the lucky winner for that copy of Serverless Architectures on AWS second edition, because there's a chapter in there in the MEEP that we talk about exactly how you can do this with Peter Spassky from a Cloud Guru, which is something that they actually do in production. And then there's also a Food Panda, which is a food delivery service that uses step function to manage the food delivery experience, from finding available drivers to, which is potentially a long-running process, to running the assignment algorithm and dispatching the driver and telling the customer and so on and so forth. So the entire order journey is managed using step functions. And The Guardian, which is a big newspaper in the UK, they manage their subscription fulfillment process with step functions, a lot of talking to Salesforce and other payment systems and so on and so forth. And the Yelp manages their subscription billing with step functions. And my my previous company, the Zone, which I hope some of you guys know in Canada, because there's a big sports streaming platform. I think they show a lot of sports in Canada. So we use the step functions very heavily in the payments teams, where we implemented a lot of our payment processing and the subscription fulfillment systems with step functions as well. And I can tell you from experience that this is a drastically simplified version of the payment processing state machine that we had in production. The real one had a lot more branching logic because of all the different failure cases you can have with these car payment systems that you talk to. So finally, let's talk about some design patterns. I guess a rather famous one is the Saga pattern, which which is a pattern for managing failures in a distributed transaction. And it's a quite common challenge in microservices where we often have to call different APIs to complete a single user transaction. So if we use a very simple example of booking a trip, even though none of us have done that for a while, where we need to complete the booking for hotel, flight, and car rental in a single transaction. But of course, all of these are separate systems, right? All of which might be external systems, and they can all fail for a number of different reasons. The room is no longer available, or the flight price have changed, or maybe the system is just down altogether. So when you try to book a car rental, it's just the file freeze. So for each of these actions in a transaction, booking a hotel, a flight, and booking a rental, we can have a task state to represent each. And for each action, we will have an equal and opposite compensating action for canceling the hotel booking, for canceling the flight, and for canceling the car rental. So in the happy path, we'll book the flight, the hotel, the car rental, and complete the transaction. But for the failure paths, we need to roll back any changes that we have done so far, including rolling back any changes that we did in the previous steps in the workflow. For example, after booking a hotel, if we couldn't book the flight, then we need to roll back the hotel booking as well as any intermediate changes that we've done for the flight booking. So if you look at the book flight state, for example, its next attribute points to the book rental on the successful path. But in the catch clause, it says that if it fails for whatever reason, then go to the cancel flight state instead, where we can then clean up any changes we've made so far for the flight booking, maybe record some additional detail about the failure, like why did it fail? And then in the cancel flight state, our next attribute now points to the cancel hotel state, which would then roll back any hotel bookings we've made as part of this transaction. And if it's quite interesting here that we also have this self recursion going on. This is because we also have a catch clause that would retry the cancel flight state if it fails for whatever reason. So in practice, this is probably going to be overkill. Some system errors may never be recoverable, even doesn't matter how many times you retry. So instead, you should probably have instead of having a catch-all to just keep retrying, you should probably have some retry clause here where you can specify the maximum number of retries and so on. And if it still fails after all of that, then you can send it to a human operator to investigate. So the code for the whole example you see here is available on GitHub, so feel free to go and play around with it yourself afterwards. And with step functions, you can also implement callbacks whereby you wait for some external signal. Maybe someone clicking on a button on the website or a link that you send in an email to complete the actual process. So this could be, I've heard people use this to implement the approval processes where you kick off the step. One step would be to execution, and one step is to send an email with a link that someone can click in the email, then comes back to continue the execution to actually then go ahead and execute whatever it was that you're trying to look for, get approval for. So you can use this. You can do this with this feature called a task token, whereby imagine we have a state machine. So one of the states is going to publish a message to SQS, and we can ask step function to generate a task token at this point and include it in the message payload to SQS. And whatever that will put our state machine into a sleep state while it's waiting for the token to be acknowledged and completed. So when somebody, whatever that is, it could be a Lambda function, it could be some containers, it could be some on-premises application you have running that's polling SQS. They can process the message and then do what they need to do. We don't really care here. What we care about is that when they're done, they tell the state machine what happened by calling send task success or send task failure against the step functions API with the task token that we gave them in the first place in the message payload. So this allows step functions to then record the outcome for our task and then move our execution along to the next state. And this is what that code is going to look like, whereby for sending messages to SQS, we have to use this special ARN, which tells step functions to call SQS get send message. And because we want to And because we added the dot wait for task token suffix, it tells step functions to generate a task token, and that it should stop the execution and wait for the outcome from the task token. And then to access the task token itself, we can use the double $ notation to access the current execution context, which contains a bunch of other useful things like execution ID, input, and so on and so forth. And of course, the task token that we're looking for as well. But all of this can be accessed through the double $ symbol for the execution context. Now, the downside of this approach is that whoever is processing our message needs access to step functions, which is fine if it's something that's running in our AWS account, but it'd be awkward if it's not. So it'd be much nicer if we say expose a HTTP endpoint that they can hit instead, like a callback URL, which then calls step functions on their behalf without having to give them any permissions to step functions directly. So this is especially useful for dealing with third-party services or to support callback URLs for emails and so on. So if that's what you're doing, then check out this application in the Serverless application repository from Ben Cahill, the aforementioned Ben Cahill from iRobot, which wraps this HTTP API up for you as a SAR that you can easily deploy into your AWS account. And of course, this callback pattern is not limited to SQS. You can also use it with most other services that step functions integrates with, including Lambda. So if you want to send out those emails and wait for a user to click on the link, then you can pass the token to Lambda, and that Lambda function can call SES to send an email and so on. And then the last pattern I want to talk about is MapReduce, which makes use of the dynamic parallelism we get with the map states so that we can trigger many concurrent workers or Lambda functions to process items in an array. Each one of them is going to produce some output. And the nice thing about the map state is that it will collect all these different results or outputs from the Lambda functions or the task state for us and put them into an ordered array. So positionally, the output is going to match up with the input array. You can then have another step in the workflow to run some reducer logic over this output, which really simplifies some of this MapReduce task. And similar to this, basically, you can do with the video encoding example we talked about earlier with Thomson Reuters, whereby you take the original segment, you split them into an array of subsegments, and then you can use map state to map over them to generate different encoded segments, and then you have the reducer step to then stitch them together using FFmpeg. One thing to keep in mind, though, is that there's a limit to the current execution state for the dollar symbol, which is 32K, which is not a lot. So if you need to pass along large objects, so what you should do is put those results into S3 and have those individual mapped outputs return just the path to the objects in S3, so that reducer can then go and fetch them itself. And so this is how you can work around the size limit when you've got a really large MapReduce task. And that's kind of the end of the presentation, which just brings us right to the hour mark. As I mentioned earlier, I work mostly as an independent consultant, and I'd love to have a chat to see how we might be able to work together and how I can help you guys accelerate product or feature development using serverless technologies. And also, my 2 self-published video courses, including the one on the step functions, is available on theburningman.com/courses, and is half price during September. So if you want to learn Lambda best practices or learn how to use step functions with bite-sized lessons, then go and check it out. And so with that, thank you so much for your time and attention. And I guess if you guys have any questions, I'm happy to take them now as well.
Wow. Thank you so much. This is awesome.
Thanks.
I know you guys are going to be for a treat. I love design patterns part, especially. I kept pasting in here. So people were typing in questions as you were talking. Like, maybe you can go through the chat and just see. Like, I know you told me you have to leave around 6:30, so I hope you have 30 minutes for people that wanted to get some of your time. And
yep, sure. So let's see. So let's go to the chat and see whether or not there's any questions. Okay, so there's a question here from Doug. Any tips for payload management in the Saga step function scenario? Using the on error and the on success cedes some control over payload from Lambda task. So this is whereby if your function returns an error, then it's going to basically override the current execution state. I think that's what he meant. So this is where in the catch state, you can add the result path so that when an exception happens, the exception is then captured, and you can then put it into a specific attribute so that it doesn't override the current execution state, so that by the time you move to the next state, you want to do some automated error handling and so on, you lose the actual context of what was the original request. So that's how I would normally do that, so that I would combine result path with catch clause in my state machine definition. And let's see. Another question from Sukasis. Do we need IAM rules permissions between the various tasks in step functions? Yes, you do. So if you use the Serverless step functions plugin, what the plugin also does is it looks at your step functions definition and see what resources you access. So if your state machine is invoking Lambda functions or is sending message to SQS, then the plugin also works out what the correct and the restrictive IAM role permission you need, and then it's going to add that to, it's going to collect them, and then it's going to spit out an IAM role for the step functions, so that the step functions can only access the resource that are specified in your state machine definition. Alternatively, you can also just handcraft your IAM role and then reference that in your state machine definition. Yeah, Piotr says it's midnight in Europe. Yeah, same here. But the recording is going to be available afterwards, so you can also watch it. Got a question from Emmanuel here. How friendly or unfriendly is step functions development environment? Can a developer unit test it locally? Local development wise, you can. There is a AWS publisher tool called the Step Functions Local, so you can use that. But typically, what I do is I test the individual components itself. So if I've got task states that I'm using to do something, then I'll test those locally using unit tests and whatnot. Because again, those are just input output. And if it's doing some side effects, then I'll, as part of my test, I'll run the function locally, and I make sure that, say, if it's supposed to write some data to DynamDB, the data is written after the function runs. But I don't tend to test the step function itself locally. I tend to do that as my end-to-end test, where I'll trigger the functions through whatever means it's normally triggered with, but then I inspect the sort of input and output and the side effects that it should generate. But you could use the step functions local to sort of simulate it, but I don't tend to do those very much. Another follow-up question with Emmanuel. If step functions is typically 15 times costlier than Lambda, how about the comparison of microservices implementation as step functions versus microservices implemented as EC2 AMI? So I guess it's expensive service, but at the same time, it's only pay as you go. So it may be 15 times more expensive than Lambda per unit, but if you only run them once every week, does it really matter? Probably not. I mean, especially if you only use it for business critical things. Like I said, if my payment workflow is the one that makes sure that everyone gets paid. So I typically use those for things that makes the company money or are so critical that I'm happy to pay the premium for the extra robustness that it offers me. That said, if you're using them using highly transactional workload, then express workflows may be a better option because they are much cheaper. And the thing that you need to look at as well in terms of this is just not just a step function, it's just a serverless. When you think about serverless, is don't just look at what's on your AWS bill. The biggest cost saving and a company can have from going serverless is in the staffing cost. Imagine how many people you need to hire to manage and look after your Kubernetes cluster. I mean, most companies that I've worked with have to hire a whole team to look after the Kubernetes cluster, and those engineers are not cheap. So imagine if you don't have to have all that entire team to look after your containerized environment, because it's all handled by AWS. The cost saving there is far, far significant than what you may see as additional pounds or dollars or whatever on your AWS bill. So look at the total cost of ownership, not just the operational cost on the say Lambda or step functions. And to build the equivalent of a step function yourself, you absolutely could. But how much energy and how much developer time you're going to put into that to build it and to support it, factor those costs into your decision as well. And I've seen some studies from AWS and from other people that looks at the total cost of ownership for serverless in the enterprise environment, and you're looking at really, really significant costs in the sort of millions and millions for large teams. So, not to say that there is one way or the other, but think about the total cost of ownership.
Thanks very much.
Okay, no worries. And then let's see if there's any more questions.
Girish, what was now?
Okay, Girish. Girish says we use step functions extensively for the order processing, sending to downstream systems. We use multiple Lambda functions and have several exponential backoffs implemented to try up to 12 hours. Yeah, so you can't do that with Lambda, right? But with step functions, it's fine to just retry with really high significant exponential backoff. Got a question here from Rajnish. If a specific task fails, even after multiple retries, will the step functions move to the next state in the flow or just stop executing? So if you don't have any sort of catch or retry that redirects failed executions to another path, then the default behavior is you stop, and you would the execution would end in a failed state. But if you don't want that, then the way you can do is you put a catch clause, and you say if it gets if after all the retries it still failed, then it goes into catch clause, and then you can say when it's caught. So in your try catch, send it to a different state. Maybe you want to do some automated error handling, or maybe just send the message to some human operator by SNS or whatever. So you have a lot of control around how you do the error handling.
Thank you.
Okay, Girish answered his question as well. Let's see, anything else? Got a question from Alexander. Is it possible to cover step functions state machine with unit tests? What's the strategy testing? So I guess similar question to earlier. So it's you could test them with step function local, but I don't tend to do that. I don't tend to trust any of the local simulators. I don't tend to work with them because I find they tend to spend it takes a lot of time to set up right, and then they're quite brittle. And I've got the same feeling with local stack and other things like that as well. So where I'm testing the step functions state machine definition itself, not the major task, I tend to do that in my end-to-end tests. Got a question from Mark. What's your preference for doing step functions serverless framework with a plugin or SAM? What's your preference between the two? So I guess that depends on whether or not you typically use serverless framework or SAM. Also, full disclosure, I'm the core maintainer for the serverless framework plugin for step functions. So that kind of tells you my preference. Personally, I prefer the serverless framework over SAM because with SAM is great and all, and it's progressed a lot in the last couple of years. But SAM, you are stuck with what SAM decides to do. So if there's something that SAM decides to do differently to what you want, you're kind of stuck. There's no plugin system that you can modify the CloudFormation template before it gets deployed. On a customer project a while back, we had one thing that we didn't agree. We wanted to do it differently. The only way we can do that was by writing a custom CloudFormation macro that modifies the template that SAM generates. After it's hit CloudFormation, then it runs our custom macro to modify literally 2 lines of CloudFormation template. That's the only way we could to that we found to disagree with SAM. Whereas with the server framework, there's the whole ecosystem of plugins, which for one lets you to do a lot of things that the framework doesn't do by default. But also, if you don't agree with with something that framework does, just either find a plugin that do it differently, or write a plugin yourself to modify the CloudFormation template. So that's why my preference is usually to work with a server framework, unless the client needs to work with SAM. And if you're using server framework, then the step functions plugin is kind of your go-to solution for working with step functions.
Super, thank you.
Cool. And then I think question from JP here: can step functions be run offline on local host with the server framework? Not the server framework. Or maybe there is a plugin that basically you can run the step functions offline with the step functions offline thing that the AWS ship. Is similar to like DynamoDB local. I'm not sure if there's a plugin that lets you hook up to the server framework to do that directly. I'm not sure. And last one from IT Alerts. Interesting name. Can you insert get data directly on a task definition? From DynamoDB, yes. So in a task definition, you can have a DynamoDB get item or put item. So you can basically have step functions talk to DynamoDB directly without going through a Lambda function, which helps with some stuff like late, or I guess Lambda cost if you're concerned about that, but also potentially cold start for the end-to-end execution time and all that as well. All right, a lot of questions. Thank you.
We have 15 more minutes before we'll have to give you back to your wife. Any other questions, or I should ask mine too? Any other questions in the forum, or you can speak up, guys? Or you see, like, this is a niche topic because like we had to choose something unique, but Yan is specialist on anything serverless. It does not have to be a step function related topic, so feel free to shoot. And I will, until you get courage or type in your question, I will ask for myself. Like I sent you email when you were preparing for this meetup. I always like to know why certain framework, why not the other opportunity. So let me share the screen while they're typing. Like I'm noticing, so share entire screen, screen 2, share, that's you. So okay, so let's see the survey. 35 people did the survey. So you still have, like, some of you didn't do it. Go through that, because we're going to be drawing the one of two. Like you will be giving away 2 of Jan's products. So today you are in for a treat. He's giving 50% discount on each courses, and Manning is giving 2 of the free products for free. The left one is a course. The second one is a book, and I have to thank you, because Peter's book was like one of the earliest products there, but it became obsolete because they wrote it when A Cloud Guru was becoming popular. So if it wasn't for you, I don't know if the second release would ever come out. So thank you for pushing that through. So, but that wasn't my question. So the question was, yeah, it's PDFs still. So look at this here. Like there is more and more reference to Apache Airflow. Like even the guys in SageMaker are talking about it. Then there is these these are recent articles: Airflow versus Spotify, Luigi, other management tools, and then Metaflow by Netflix. They're combining with step functions. So like we treat step function as the other kid on the block, but there are other options. Thoughts, like just in a context before people blindly jump in and to use them. So how, like you're expert on this topic, but in a context of a workflow topic, what can you tell us?
Yeah, so I think most workflows, they offer very similar things in terms of letting you model your business workflows and handles the orchestration, all of that. There's also Camunda as well, which is also quite a popular workflow engine. I guess the main question there is, well, do you want to manage infrastructure? So a lot of these open source solutions are open source in terms of the code, but you have to run it yourself, right? So again, that brings me back into the world of having to manage and scale and make the infrastructure robust, which again, unless I'm an infrastructure company, that's not where I can add value. So the serverless, the promise is for me to focus on what's important to my customers and build the things that only I can build. So when it comes to a lot of these frameworks, most of them they're not a service that you can just run. Yes, something that you have to deploy, you have to roll out updates and all of that, which straight away means that for me is kind of no. I don't want to be managing infrastructure. I don't want to be being woken up at 3 a.m. in the morning because some server died in US East 1. So for me, a lot of those is a straight no. But for there's a couple of them that now start to offer cloud services. Camunda, for example, offers cloud service, and they have got integration with Lambda as well. So as far as I'm concerned, if something that can that I can get as a service, it's got the good, I guess, a good scalability and resilience, and it can integrate with Lambda for compute, then that's good enough for me. Whether or not it doesn't have to be step functions. Step function is just something AWS offers out of the box, so don't have to worry about anything else. Just use it as a service. Integrates with IAM and all that, but anything else that can tick similar boxes are just as good for as far as I'm concerned.
I like that. Actually, like the fact that you don't have to do decision making what to use gives you agility, because you use what your cloud provider offers and just move on. And I think like when in early 2000, when Java was picking up, like there were so many frameworks, like we were wasting thirds of the project just deciding which framework for logging to use.
Yep.
Microsoft came with the opinionated .NET framework for logging, and people started switching because they were saving the time. So by committing to step functions, you're really achieving agility without thinking, not to mention managing and patching servers.
Like I said earlier, right? It's about the serverless mindset. It's about focusing on value creation as opposed to running infrastructure. So if there are, I'm sure there are lots of tools, lots of options, but unless they allow me to follow that serverless mindset, allow me to focus on business value, creating business value, it's straight a no. I mean, this is quite easy decision.
So on that note, I think there was a thread started by Ben Cui about making decisions in the serverless, which tools to use. So the first one would be, if the service is managed, then go for it. It's not my uptime. I just get SLA and I use it. Second one was, if my cloud provider where the solution is running has the service, use that one. If not, then like use from maybe other APIs, other providers, and only then build products if you have to. So it becomes like 1/3 or less of the solution, and that's where this mindset falls in. So okay, there was one more question. It's not step functions. No, it is. Does it call start occur for every Lambda function that is executed on the step function by Fabio?
No, so I guess it depends. There's nothing systematic about when the call start happens when it's executed by step functions. If step functions calls the Lambda function, and there's no freely available worker or thing containers that can execute for that can handle that request, there will be a cold start. But if there's warm containers already, then there won't be a cold start. So it follows the same rules that Lambda has for execution. Because remember, all these different services that you integrate with Lambda, they're all different services. So when there's an API gateway invoking a Lambda function, that actually happens through an API call to the internal front end that the Lambda service has, which then checks, is there a free container that's running for this function? If yes, then we're going to use the existing container. If no, then we're going to create a new container, or they call it worker, and then we're going to ask the new worker to handle that request, and that being a new container is a cold start.
Mm-hmm.
So if you actually want to learn a bit more about how Lambda and all that works under the hood, there's a section called Lambda Under the Hood from reInvent last year. I'm going to put in the chat here. Really good talk. Tells you a lot about some of the internal sort of architecture that the Lambda service itself has.
Mm-hmm. Nice. So we still have 10 more minutes before Yan goes. Any other question, or I should give his books away? Anybody wants to say hi? I saw Jonathan posting. Hi, Jonathan. Did we forget anything in this meetup? Because we have only 10 more minutes.
Oh, hi, Daniel. Yeah, sorry I was late, guys. But
no, that's okay. It was unplanned early. Normally
yeah,
it's 6, but
you
were like,
schedule,
happy life.
Well, I'm actually still at the clients here in the city, but I'm just watching it. It was excellent presentation of the product. Sorry, I can't wait to see the video when you post it. but no, I didn't have any other comments or questions, but what I saw was fantastic. Yeah.
Thank you.
It's easy with Yan. He's always fantastic. Like, I cannot read fast enough how fast you can write. I'm behind. I was trying to catch up for this meetup, and I couldn't. So okay. So let's see for the draw. So where are the